As we know that the modulus function is defined in the previous video, and now we'll define the modulus function with the three main postulates. Number one, by graphical method. Second is solution of equations. And third, solution of inequalities. But we will define the simple example first, and then we will find the second complicated example related to this topic of modulus function. Suppose you have to solve x plus 2 modulus is equal to 1. So first of all, we are going to use it for the graphical method. For this, let y is equal to x plus 2 modulus is equal to 1. This means y is equal to x plus 2 modulus and y is equal to 1. We know from this that if it is x and y-axis there, then y is equal to x plus 2 will be the graph of this. And y is equal to 1 is the graph of this. But we just find out that there are two solutions possible at this point A and B to that. But we don't know the exact solution of this. Now we will solve it with the equation of that. The second method, x plus 2 modulus is equal to 1. You have two options here. First, x modulus is equal to plus minus x. So when we remove this modulus, you use plus minus x plus 2 is equal to 1. This will be x plus 2 is equal to 1 or x is equal to minus 1. Or minus x plus 2 is equal to 1. Then minus x minus 2 is equal to 1. Minus x is equal to 3 or x is equal to minus 3 for that. So these are the A and the B solution, which is equal to minus 1 and minus 3. Then the B option for this part is by using this property, x plus 2 modulus is equal to 1. That means x plus 2 square and then square root. That thing is equal to 1. Or x plus 2 whole square is equal to 1. This is square there. So x plus 2 is equal to plus minus 1. So x is equal to minus 1 and minus 3. Or if we use the same method there, x plus 2 square is equal to 1, then x square plus 4x plus 4 is equal to 1, or x square plus 4x minus 3 is equal to 0. So plus 3 is equal to 0. 4 minus 1 is plus 3. If we factorize this thing as x square plus 3x plus x plus 3 equal to 0, then taking x common, it should be x plus 3. 1 is common, it should be x plus 3 is equal to 0, or x plus 3 into x plus 1 equal to 0. So either x plus 3 equal to 0 or x plus 1 equal to 0. So x is equal to minus 3 and minus 1, which is the same solution as we have obtained in this first part and the second part there. Then for this third part, using equalities in that function. So x plus 2 modulus, let's say it is less than 3. So if we remove this modulus, x plus 2 square and then square root is less than 3. Or x square plus is equal to 1 plus 4x plus 4 is less than 1. Or x square plus 4x plus 3 is less than 0. Now we use this critical solution. That means you are taking this x square plus 4x plus 3 equal to 0. As this we have already factorized, so x answer would be equal to minus 3 and minus 1. Now you draw the inequality graph for this part. This is x-axis, this is y-axis, this is minus 1, this is minus 3. Since x square coefficient is 1 there, which is a positive number, so the shape of this graph will be the minima and it will pass from these 2 points. So now we know that our main thing is x square plus 4x plus 3 is less than 0. So this is the point where it is less than 0. So solution of this problem is x is greater than minus 3, less than minus 1. This is the way that you are going to solve this question with the 3 methods. One with the graphical method, then with the equation solution, and then with the inequality solution there. So you have to be confident about these 3 methods, which will be used in the later on in the next videos for this chapter there.